All right, Algebra 1B students, welcome to part 1 of lesson 10.2. Tonight we will be simplifying square roots, or simplifying radicals, as your book calls them. On Monday, and up until this point in the class, when we've done a square root, we've just used our calculator to get a decimal approximation for that square root. Today, we will not be using our calculator to get a decimal approximation for a square root. We will be simplifying the square root as much as we possibly can and leaving a square root in our answer. You'll see what I mean in just a minute. But first, I would like to list some perfect square numbers that I would like for you to list in your notes, please, for you to use on your practice problems tomorrow. Okay, so make sure these end up in your notes. A list of perfect square numbers. The first is 1, because that is 1 squared. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. And let's keep going. Let's just list the rest of them. 8 squared is 64. 9 squared is 81. 10 squared is 100. That should be enough for us for right now. This is a list of perfect square numbers that we are going to use to help us simplify square roots that are not those nice, easy numbers, right? Because we know if I take the square root of 4, I get 2. If I take the square root of 9, I get 3 or negative 3, right? 3 or negative 3. If I take the square root of 16, I get 4 or negative 4, and so on. We are going to be simplifying, in this case, in this lesson, square roots that do not come out nice and even, like 5 and negative 5, or 4 and negative 4, but have some crazy long decimal. These perfect square numbers are going to be very important, because we are going to be looking for perfect square numbers that are factors of the number under our square root symbol. So we're looking for perfect square numbers that are factors of the number under our square root symbol. For example, if I want to find the square root of 32, I need to look for a perfect square number that can divide evenly into 32, and I want to find the highest one I possibly can to reduce my workload as much as possible. Okay? Let's think through some of our perfect square numbers and see if they will divide evenly into 32. 1 obviously will, but we'll never, ever, ever use 1. So you can skip that one when you're looking at your list. We'll never use 1 in our cases to simplify square roots. 4 does go into 32. 4 times 8 would be 32. So I'll keep that one in mind and see if I can find a better one. 9 does not go into 32. 16 does go into 32 because 16 times 2 is 32. So, so far this one wins. I'm not going to use 4. 25 does not go into 32, and the next one up was 36, so I'm already too high. That's not going to work. I'm going to want to use 16. Okay, 16 is the perfect square number that goes into 32. 16 is the highest one. So, I'm going to rewrite my square root of 32 like this. The square root of 16 times 2. I'm just splitting my 32 into the two numbers that I know it can multiply to get 32, one of which must be a perfect square number. In this case, this one is the perfect square number. Now, once I have it written square root of 16 times 2, there's a special rule of square roots that says it's perfectly okay for me to split that square root. Okay, so instead of saying the square root of 16 times 2, I'm going to say the square root of 16 times the square root of 2. I am allowed to do that as long as it's only multiplying underneath the square root. Okay? 16 times 2, square root of 16 times square root of 2. Since we know that the square root of 16 is equal to 4, I can replace this piece with a 4, which means my final answer is 4 times the square root of 2. So the square root of 32 equals 4 times the square root of 2. That is a perfectly simplified answer because there is no perfect square besides 1 that goes into the 2. This is a very small number. That's what I'm hoping for. Some very small numbers there. Okay? If you have questions about that process I just went through, please make a note to ask me in class tomorrow or rewatch what I just explained if you missed something. But I went from the square root of 32 to 4 times the square root of 2 by splitting 32 into 16 and 2, taking the square root of 16, which I know is 4. Okay. Let me show you a few more examples, starting with the square root of 50. If I go through my list of perfect square numbers to go into 50, I'm going to skip 1. 4 does not work. 9 does not work. 16 does not work. 25 most definitely does work. And that's the last one. 36 doesn't. 49 doesn't. Okay, so I'm going to use 25. I'm going to split the square root of 50 into the square root of 25 times 2, which is really the square root of 25 times the square root of 2. And I know that the square root of 25 is 5 square root of 2. Now, one thing that I forgot in the previous problem, I apologize for that, but whenever I take a square root of 25, we know that it could be more than just 5, couldn't it? It could be positive 5 or negative 5. So to finish my answer, I'm actually going to write it like this. Positive or negative 5 square root of 2. Positive or negative 5 square root of 2. Either one of those works. 2 possible answers again. 5 square root of 2 or negative 5 square root of 2. And we use this little plus or minus symbol here to denote that. Now let's try another one. But this time, I'm going to put a number out in front of it. Let's simplify 2 times the square root of 18. So I'm going to simplify the square root of 18 first and then deal with my multiplying by 2 later. So forget about this guy for a second. And just look at 18. Think of some square roots, perfect square numbers that can go in there. 4 doesn't, 9 definitely does. 16 does not, and that's all I have. So I'm going to use 9. The square root of 18, or 2 times the square root of 18, really is 2 times the square root of 9 times 2. Since I have the square root of 9 times 2 here, I know that that's really, okay, 2 times the square root of 9 times the square root of 2, which equals 2 times plus or minus 3 times the square root of 2. Because the square root of 9 is 3. So I've just split the 18 into 9 and 2. Square root of 9 is 3. Square root of 2 I leave that way because I don't know what the square root of 2 is. Okay? Now, I have 2 times all of that. So 2 times a positive 3 square root of 2 would give me 6 square root of 2. 2 times a negative 3 would give me a negative 6, so I just do a positive or negative 6 square root of 2. Okay, and that just comes from, once I finish my 18, I have 3 square root of 2, I multiply the 3 times 2, put those 2 together, and I get plus or minus 6 times the square root of 2. Okay. Let's add variables. I will also expect you to be able to simplify this kind of square root right here. Square root of 8x squared. Now, when I have variables, I need to deal with each separately. I will start with the number. Under my square root I have an 8. I need to find a perfect square number that goes in there. The first one is nice. it's 4. I know that goes in there and already at 9 I'm too high, so it must be 4. So I know that I'm going to split the 8 into 4 and 2. Now x squared is already a perfect square number, because I hope that we remember that the square root of x squared is equal to x, because x squared is really x times itself. So I'm undoing timesing it by itself, and that's x. So I'm going to split my number into 4 times 2 times, still have x squared out on the end. 4 times 2 times x squared. Then I will split my square root of 4 times square root of 2 times square root of x squared. I can do it 3 times as well. Oops, excuse me, x squared. And now 2 of these square roots, I actually know what the answer is. The square root of 4 is positive or negative 2. The square root of x squared is positive or negative x. And I still have a square root of 2 on the end that I don't know the square root of. So my final answer when I simplify this is positive or negative 2x square root of 2. One more example for you before I have you do some on your own. The square root of 48x to the 4th. Again, I'm going to deal separately with 48 and x to the 4th. I'll start with 48 by looking for a perfect square number that goes into 48. So that I can split that up and simplify. I'll start with 4. I believe that goes in, but I'm going to try to find a bigger one in this case. 9 does not work. 16 does work because 16 times 3 is equal to 48. This is going to be my biggest right here. So when I simplify square root of 48x to the 4th, I am going to split the 48 into 16 and 3. 16 and 3. Now when I deal with the x to the 4th, just kidding, I'm actually going to make that an x to the 6th. Let's make that x to the 6th. When I deal with the x to the 6th, I am going to split x to the 6th into 2 things that I know are the same. So what I want to remind you of in this case is that x to the 6th is equal to x to the 3rd times x to the 3rd. Because remember, when we multiply numbers with the same base, different exponents, or the same exponent, we just add the exponents together. 3 and 3 is 6. Right? So if I rewrite x to the 6th as x to the 3rd times x to the 3rd, then the square root of x to the 6th is x to the 3rd. X to the 3rd. Okay? So if you have an x to some exponent under a square root, just divide that square root in half, and that's what the square root is. So x squared goes to x to the 4th goes to x squared, x to the 6th goes to x to the 3rd, and so on and so on and so on. Okay? So x to the 6th square root will end up being x to the 3rd. Now again, I'm going to split my 48 into 16 times 3. I'm still timesing by x to the 6th. Now I'm going to split the square root symbol around it. Square root of 16 times square root of 3 times square root of x to the 6th. Okay? I know that the square root of 16 is positive or negative 4. I know that the square root of x to the 6th, I cut the 6 in half and it's x to the 3rd. And I still have a square root of 3 on the end that I do not know the answer to. Please note that I still have a plus or minus in the front. And that is how I simplify square roots with an exponent. Now I would like you to try these two that have exponents in them. Square root of 75x to the 4th, square root of 98x squared. Okay, deal with each separately. But pause the video, split your number, find the square root of your x piece, and simplify that square root. Reminder that you should have a square root at the end of your answer. Pause the video, take a look at those two, and then come on back. I'll show you what we should get. This answer should be plus or minus 5x squared times the square root of 3. Split the 75 into 25 and 3. 25 and 3. Square root of x squared is, square root of x to the fourth is x squared. Over here, this should split into 7x square root of 2 plus or minus, obviously. Because 49 goes into 98 two times. And the square root of 49 is 7. Plus or minus 7x. Square root of x squared is x. 49 and 2 is what we split into there. If you have questions about this, we're going to work on this tomorrow and potentially the day after that as well. If you have questions, make a note to ask me in class tomorrow. Otherwise, that's all I have for you tonight. Have a wonderful night.